Today we are going to look at Mastra AI. Mastra AI is another agentic framework which has been really targeted at the front end JavaScript development community. So all this while we have been talking about you know different SDKs and frameworks for building artificial intelligence, for building agents and so on. And we've really been talking a lot around LangChain. There is LangChain Python and there is LangChain um, TypeScript, JavaScript, right? Even though it does look like LangChain is also kind of finding its way to other languages. But you always tend to have this feeling that LangChain kind of always is first class a Python framework. It's always first and foremost a Python framework. And then, but the TypeScript aspect of it is just brought in to carry front end developers along. But when you look at LangChain as a front end, as a TypeScript framework, you will always tend to see that um, it's still more of backend, right? It's a TypeScript framework, but it's still more of backend. You are still building endpoints, you are still building servers, even though you could use it in the front end context now, especially since it has evolved a lot in the last 1 year. So you probably can use it more in the front end now, but you still get the sense that LangChain feels more like a backend framework. So even with TypeScript, JavaScript, you are still building something more or less like backends. Now, that is where Mastra comes in. Mastra comes in to kind of close that gap. It's almost like, okay, Python has been getting all the love, but nobody has really paid attention to front-end developers. So Mastra that's what it is. It is an AI agentic framework that is really targeted at front-end developers. It's TypeScript native and it has a lot of features of its own. So of course, Mastra is much more recent than LangChain. I think LangChain, this should be its fourth year, I think, while Mastra is more or less in the second year of its existence and evolution. So, but we'll talk about that and then we'll talk about core abstractions of Mastra. It's still kind of same similar things, right? We would still talk about the same things, agents, workflows. Mastra has what we call workflows, which more or less are similar to LangChain's chains, right? Then streaming, which, then we'll talk about MCP as well. So we already kind of did an overview of MCP as a protocol that allows AI to connect with knowledge, with context, with tooling, you know, in a uniform way, no matter where those things are. So we'll talk about memory as well, talk about RAG, talk about workspaces. Workspaces is a new concept brought in by Mastra. So workspaces allow you to constrain your entire ecosystem of agents and tools and whatever into a single space that is kind of sandboxed. And so that way you can restrict access and things like that. Then we'll talk about servers, deployment. Yes, Mastra makes it easy to do observability as well. And even when you want to talk about things like evals, evaluation, and then there are a bunch of new features coming in as well, voice, um, and multi-agent orchestration, and a whole bunch of other things. We will not have enough time to go through all of them, but we'll just go through quickly. Then we'll also learn how to set up a Mastra project. Um, Mastra kind of can exist side by side with any front-end framework like Next.js, React.js, or Vue.js, Nuxt.js, or any other front-end framework. which you can then use to connect to Mastra. Um, and then we'll end up with a little hands-on mini project where we'll create a simple front-end AI agent and implement a few tool calls that will give you the capability to do web URL summarization. Okay. Um, then of course we'll use the Mastra Studio. So that's one other thing. Mastra comes with a playground, a very um, you know, simple to use, nice to use playground that allows you to interact with the agents that you create live. So it makes it easy for you to test and try out your agents, right? Okay, so we may have already seen this before, okay, but I'll still want us to take a look at it again. So you can see that there's a paradigm shift in how um, we deal with the whole software development stack, right? We talked about that earlier. But we also have seen that just in the last 2 or 3 years, right, the way we architect AI applications has changed drastically. Before what we were just doing is you have a front end that will just transfer a prompt from the user to the LLM, right? And then the response from the LLM, it returns it back to the user. So it was as simple as that. Nothing complex, nothing major. All of the work was being done by the LLM at the back end. So if the LLM was hallucinating, well, that same hallucination will be passed back to the user and all whatnot. Whatever capabilities the LLM has, that is what you know your app has. Whatever um, you know things that um, your LLM is incapable of doing, right? Those same challenges are also, what will be transmitted back to the users. So, but things have changed. Things have changed a lot. Um, these days, from 2005, towards the end of 2005 and 2006, right, you find that modern AI apps, you can see the stack is richer. There's a lot more in it. Okay. So the user interacts with an agent, right? No more the LLM directly. Of course, the user is going to build the prompt, but the agent is much more intelligent now that the before the burden of writing a good prompt had to be on the user. Not that it doesn't matter right now. It still matters being able to write a good prompt. It still matters. But you can be forgiven if you didn't write a very good prompt because the agent kind of handles things. For example, it will take whatever task you give to it, it will split it, into smaller tasks, you know, uh, do a planning mode or something, through the reasoning loop. If it needs more information from the user, it will come back to ask for it and so on. So these were things that were not really available before. So the agent takes most of the flack, does most of the work. The agent now has tools, APIs, and the MCP capabilities. These additional capabilities allow the agents not just give you advice or give you responses, but to actually do stuff like we've already seen. Then we also have memory. So it's easy for you to plug in memory to your agent. It doesn't take a lot. You don't have to basically track the entire conversation yourself with your handcrafted code. It all comes together. Then um, memory, and then Mastra now adds workflows, which is kind of like sequential steps to be taken, some of which can be predetermined or deterministic, right? While others are more, you know, stochastic or probabilistic, which is based on the problem. They are more dynamic. But at the end of the day, that entire thing is what goes to the LLM. And then we now have streaming UI, which is an interesting thing. Streaming UI makes your agent appear even more intelligent because you can start sending responses back to the user almost immediately. You don't have to wait for the LLM to finish whatever it's doing, right? It passes the information back in real time. So what that means now is that um, that shift has addressed a whole bunch of problems. So these days, you cannot just call an LLM directly. It's not going to be very, like, nobody's going to be amazed by that anymore. In the good old days, in 2022, in 2023, it was a big deal that you could even have AI that will respond and do stuff. But you see, one thing with human beings is once technology becomes common, people basically get used to it. And giving back that same technology, no matter how much work you have put into it or how amazing it is, it's not really like it has become the norm. Okay. So just an LLM alone is not enough because you need to use for the LLM or the agent to do useful stuff, not just giving answers or telling people what to do. You need multi-step reasoning to be able to break down more complex tasks and problems and then take them step by step, basically a to-do list. You need persistence so that all that is going on is stored in memory or in permanent storage so that the next time you come back to resume a conversation with that agent, you're not starting from scratch. That makes the agent still appear intelligent. Observability now becomes a key element from the engineering side of things for you to be able to identify issues, if there are any issues, right, with your um, code, with your prompts, with your LLM, with whatever. Okay. Then streaming, like we've said, streaming adds times two, times three, times five, to the appearance of the intelligence and evaluation. So these days, you are not just in need of an LLM. You need an entire infrastructure, an entire harness. Okay. So this is where frameworks like Mastra, of course, even LangChain, they come in. There are lots more, right? So what is Mastra AI? Mastra is a TypeScript native agent or agent framework rather for building production AI applications. That's simply how they define themselves, right? But the key things to take note of there are one, it is TypeScript native. So it is built in TypeScript for TypeScript and it basically leverages on a lot of TypeScript features because there is no question or concern about portability between languages. It actually can lock itself into features that are only available in TypeScript or that are optimized for TypeScript. And we are going to see a bunch of them shortly when we start using it. Um, so the key design philosophy, yes, some of the things I was talking about, it type safe agents. If you're writing with Python, you may not be able to write type safety into it because Python is not necessarily type safe. Yes, there is type hints, but Python does not enforce the typing. Even though you could also arguably say that in TypeScript, JavaScript doesn't enforce the type hints. But the difference is that JavaScript will not, or TypeScript will not compile, even though there could be runtime dynamic challenges. But TypeScript still finds a way to find a large percentage of such issues because such issues would still sort of show up in the code, the way the code is written. So it's type safe. It's built for modern web stacks. It's streaming first, right? So you basically, the first primitive for invoking an agent is that it streams it, right? It's tool native as well. So it's built for you to be able to easily plug in tools. It's provider agnostic. So of course, this is the same thing as LangChain basically. And provider agnostic means you swap out providers and you can throw in what they call LLM routing. Okay, and it's production ready. So as it is, after you have finished the development phase, where you are kind of playing around with it, you can easily deploy it without having to make any huge changes. So it is kind of backend infrastructure for intelligent software. So again, you see that word backend comes in, right? Um, Now, front-end engineers love Mastra because it integrates naturally with Next.js, with Edge runtimes. An Edge runtime is a runtime that runs on small devices, small low power devices, low capability devices, right? Then server actions as well, React streaming and web sockets. Okay, so the other reason why you should pay attention to Mastra and even learn and master how to use it is because, like we said last week, the front end has evolved or is evolving. It has switched from just being a UI, user interface, that you use to display or present data and payload from the backend. It has become an intelligent interface. So your UI is not just rendering the data from the backend. It now has to be able to reason and make decisions and orchestrate tools and adapt to user context, right? And when we say user context, I think I tried to explain that a little bit some time ago. That is the fact that depending on where you are on the page, right, it knows the right thing to do or the right way to respond. You don't need to start by explaining, your current state or the current state or where you are on the website. It knows where you are, it figures it out, and it can give you contextual help that is basically, germane or relevant to where you are. So we must try to get structured primitives for building reliable agentic apps. Okay. If you didn't have Mastra, you would be managing retries by yourself, which means if you were to make an API call or something and it fails, you have to recover, catch the exception, and try again. And even that second try, if it fails again, catch the exception and try again. And sometimes you now need to figure out when to stop. You need to figure out which kind of exception is worth it to retry and which ones you should not. What they call retriable versus non-retriable errors. But Mastra handles all of those because all of these have now become primitives or basics in an AI UX, in an AI-based world. Then tool calls. Remember when we're doing tool calls manually with our prompts, we had to track everything. When the LLM returns a tool call request, we would have to go invoke it, get the response, and send it. when we send it, we have to check the response from the LLM again, whether it is a final response or whether it is still another tool call. And we have to keep doing that. So imagine having to manage that at scale or on every single project that you have to write. You have to go and redo all of that. Then chaining prompts, which we've already seen. State management, state being the current state of information or data, you know, at that point that is being sent to the LLM, because the state is part of the context. When we're saying context, right, the state forms what the LLM responds to. And like we saw, state also changes, right? And the agent or the LLM responds to that. Then streaming. So these are all the things that Mastra helps you to do. So with Mastra, you can now think about um, the different aspects that you compose. Mastra is more of a compositional framework. You build elements, right? And then you compose them, right? But then it provides for you a runtime, an application runtime, where you can put in those elements that you are composing. And when you put in those elements, you can assemble them in any way you want. You can connect them together, right? So each of those elements is what we see here as layers. So of course, the model is, remember, in the middle of the agent. The agent is able to run because it has tools, it has memory, and the RAG is, of course, exposed as a tool, but it is retrieval, its ability to access external knowledge that the model doesn't have, right? Combine that with the model. So the agent, so you build an agent from the model, right? The memory, tools, and RAG become elements that contribute to the agent. And then you can use agents to build workflows, which are steps that can be followed, to do complex tasks, right? Then you take all of this and you place them in a master server that then orchestrates all of those and provides an API. It provides an API that connects these entire thing that you've put together to the front end, which you can then use front end, use the endpoints that the server will generate to access and pull it. And it gives you a unified API. So those are the elements, right? These are some of the core ones. You have the agent, which that's a reasoning unit that's made up of the LLM, of course, and then the tools. The workflow orchestrates, agents. You can make them deterministic, like chains, or dynamic, like React, reasoning loops and so on. Then the tools are the external capabilities. Then the memory provides the persistence and conversational history. Streaming ensures that users are getting all the feedback in real time. And then it also has observability. So, of course, one other thing that is not on this slide is there is a playground that you can then use to configure all of these things and test them out. Basically, test them out, try them out, and play with the agents that you build. So the first abstraction, the agent, this is the same as any other agent. Like what we've come to know and understand as agents. It's an LLM that you have configured with instructions. So instructions is their own nomenclature for what we used to call system prompts, right? So in LangChain, OpenAI, and all the others, they are called system prompts, but Mastra calls them instructions. Then you have tools. Of course, tools are tools in both sides. It's the same thing. These are capabilities that you give to the agent to be able to actually do stuff within your control. You have memory. Memory is memory as well. It is basically a storage for the agent to use to keep track of history, of state, and of context if needed. Then we have output behavior. So the agent, from Mastra standpoint, the agent is the brain of your app. You always start off with the agent. The agent is the basic primitive. In fact, in Mastra, you will not hear so much about LLM. LLM is absorbed, right? LLM is like, think of LLM like a proton, you know, in elemental chemistry or physics. It is a smaller mini, sub part of the agent. The agent is the basic primitive in Mastra. So you start with the agent, right? There's nothing like, oh, here's an LLM, or you can do stuff with LLM directly. You cannot actually, well, I don't know, I need to think about that, but you cannot directly do stuff with LLM in Mastra, unlike in LangChain, where you could actually you know, spin up chat OpenAI or chat this LLM chat model and then run an API call, right? And it does things. There's nothing like that in Mastra. In Mastra, the basic unit is agent. So if you want to have an agent that is an LLM, that means if you want to have an LLM, you basically are creating an agent without giving it any tools, without giving it any memory, without giving it anything. There is just a bare LLM, right? But the master is still an agent. So that's the main difference. The basic unit, the basic primitive is the agent. And you import agent from Mastra core. That's where you import it from. Um, Even though just like with LangChain, Mastra is also undergoing a lot of you know massive updates as it is becoming more and more you know improved. It's becoming more and more mature. So you may find that what you knew today may change the next time they uh, bring up an update, right? So you import it from Mastra Core, actually Mastra Core agent directly. Okay, so this is the very basic agent you can create. As you can see, it has a name. So this is one other new introduction from Mastra. They have an ID and they have a name. The ID is required, even though it's not shown in this screenshot. ID is a required field. Name is an optional field. So the ID is a machine a machine name, right? So it has to follow the variable naming rules. It cannot have maybe, for example, spaces in it and all of that. It can be hyphen, alphanumeric 0 to 9 hyphen and maybe underscore. Then that's the ID actually. Then the name is human readable. So that's what a human being will see. Okay. Then instructions, like I said, this is basically the basic instruction that the agent will work with, right? Others call it system prompt. Okay. Astra calls it instructions. So you can put in whatever. This can be of any length. You can even import it from a saved or stored document. Then model, which is the actual LLM that you are pulling in. Mastra does not need you to provide a provider, right? You just use there's this routing nomenclature or approach that they have. Their own approach is that um, they they have uh, they have the slash, the forward slash to separate it. So, for example, this now has two elements. It has this, which is the provider, and it has this, which is a model name. And you can see that this slash is what separates them. That's kind of the pattern. The interesting thing is that um, this is totally type safe with type hints. And one thing that Mastra did very well with this is they um, have made it very easy for you. It has very good autocompletes, really. Just start typing open and it gives you all the possible open AI models that are currently available. So they keep on updating it, right? In fact, if I want to show you this, how you can just make a very simple um, model. Let's say you want to make a very simple model. I'll start from scratch because I think, yeah, rather than starting from, I had wanted to start with this code space. Okay, we are here already. So, but what I'll do, I'm going to wipe this clean. I'll check out a new branch. I'll wipe it clean, and I'll, you know, let me just show you how this works. Uh, okay, so there's some update here, which I will. So CodeSpace did some initial setup. Okay. Um, Now I'm going to change to a new branch so that we start from scratch. Um, so let me just call it new branch. Okay. So in this new branch, we will start from clean slate. Wipe everything clean. Okay. So this will take a bit of time. There's nothing here. Now, if you were to just, of course, the first thing we need to do now is to install Mastra. So we'll start by just installing Mastra Core. Okay. So I'll just do npm install Mastra Core at Mastra Core. So that's how you always start. And we'll just start with that first, just to show you that that is kind of the foundation, the primitive. Okay, so we'll come back to this. So that's what an agent is. Agent is very basic. It's a basic principle, primitive rather. Okay. Now, when you do an agent, you don't give it a tool, so it cannot do a lot. It can respond to you. It can give you meaningful answers, right, to your queries and so on. But that's about the most it can do. When you now want the agent to be capable of doing things, not just telling you things, then you bring in the tools like we have seen. And you can see the definition of a tool in Mastra is pretty straightforward. You use this tool um, function which again, you are going to bring it in from Mastra Core Tools, right? Um, then you basically pass into this function a definition of that tool. So again, you are going to have ID as well as name, right? And then a description. The name is optional these days, but ID is required. And the ID is the one that has this shape now, this fetch page, while the name is more of human readable. Then description, right? Then you now have this execute function, which is what will be executed when the agent wants to run this tool call or this tool. Okay. You have to pass in the parameters in this destructured form. Okay. Then you do whatever you need to do inside that function and you return it. That's how tools work. Right. Now, this is the basic form of it. When you have defined the tool, you then pass it into the agent, right, with this tools key, and the agent now has it available. So let's see how that works. If this has come up now, hopefully I we will now be able to um, we will now be able to do that. So let's start off by creating a new file. I'll just call it index.ts where we'll do some of these experiments. We'll have index.ts. Remember, it's a TypeScript module. So we'll import create tool from Mastra. Okay, so I'm having difficulty typing into this. I don't know why. I don't know whether it's because, so let me allow. Okay, so for some reason I cannot type into this. I don't know what's going on. Maybe the code space is malfunctioning. Let me see if I can type now. I still cannot type. Okay, so I'm going to switch to VS Code. Um, I can type in the terminal, but I cannot type in the code area for some reason. Let me restart the code space. Okay, so maybe that's what was blocking me. Too many changes to track. So putting this in Git ignore has released. All right. So I'll change this to another file. So we're trying to basically start agent from Mastra core agents, right? So that's the basic primitive is to do that. Then once you do that, um, you can then, you know, do a basic agent is just create the agent, um, give an ID, right? So you could do something like agent equals new agent, okay? Then you pass in some things. Now, the beauty of this is that because this is TypeScript, TypeScript is going to give you some nice text code completion. If you use Control and Tab, it will load the um, different, um, you know, keys, right, or properties that you need to provide. So of course, since it's TypeScript, the one that have question marks are the ones that are optional. So everything else that is did stop are required. The ID is required. The instructions are required. Instructions can also be a callable. The model is required. The model can also be a callable. The name is required. So, and not only that, it's also is um, strongly typed. So it's type safe. You cannot put a number, for example, because it uses Zod typing. It's going to give you an error that you cannot assign a number to string. So ID has to be a string, right? So my agent, right? And it also has even better than that. If I were to put a space here, it is also going to complain about it, even though maybe I'll come back to that because there are still a bunch of errors I need to resolve. So the name, then the description is also required, as you can see. And then again, um, model, instructions and model. So the instructions, like I said, this serve as the prompt, and then the model. The model, again, if you use the shift and tab, you will see a whole bunch of interesting stuff here, which I have not seen anywhere else except in Mastra, that it has autocomplete because of the type definition that has been created and associated with this particular, um, this particular property. You could actually just go with something like Open Router, for example. And you're going to get all of the Open Router that they have, kind of locked in here. Or if you wanted Grok, you could just say Grok, and you get all the Grok. Or you could say Hugging Face, right? And you get all the Hugging Face. So that's how neat this is. In fact, this is one of the things I like most about Mastra. The fact that it speeds up your development and it prevents you from making mistakes. Even if you are using agentic support, Copilot to generate your code, this provides immediate validation, right? So let's assume I want to use the regular open router I normally do, and NVIDIA, okay, Nemotron. So you see it's already kind of reducing, and I pick this, right? So you get all of those, and you get all of those for free. Now, what I was even trying to say is that the last one was the most amazing, but if I were to well, okay, so maybe this is acceptable as an ID. So this gives you a basic agent. Now, the next thing you can do is do something with the agent. For example, ask it, give it a prompt and ask it to give you a response. It's very easy. Um, you just agent dot stream, okay? Agent dot stream. So we're going to look at the streaming, later on in more detail. But what you do is stream is a function, okay? And you can see again, you get some type hinting here, the messages. And the message is a message list input. So we can go with, okay, messages. Um, yeah, messages. And then, yeah, this should actually be this should be in that form. It should be the structure, like I said earlier. So you have messages, okay, but the messages is where you bring in what we already know. Kind of, we follow the yeah. So you pass the messages indirectly. It's actually a keyword. Sorry, it's oh, okay. So the stream is a promise. So you await it. So you are waiting with then because you're not actually in a function here. And then when you get a response, by the way, stream is going to give you a generator. So you actually need to, for you to run the whole thing, you do an await. Okay. This is response, or rather stream. Let's call it stream because it's a generator actually. It's a generator. It's not an actual message, but it is something that will keep, sending out messages. So you have to loop through this stream, right? And um, oh yeah, I know I forgot it. So this should be a wait. Yeah. Okay. So you await, and then here, um, so we can then log the output. But whenever you're streaming, like we talked about the last time, I think it's always better to do process dot standard out dot write. Okay, and there shouldn't be any. Um, yeah, so this um yeah, this needs to be run in the context. Anyway, let me not do this yet because this requires node. So let's just do console.log for now. Okay, so this is something that we can just try out. So let's try out and see. And then we can just run node um, index.ts. Okay, so this actually comes up. It's not async iterable. Yeah, that doesn't seem right either. So, like I said, we actually have, probably I need to embed this in somewhere. We have, yeah, you always have the case where these things change a lot, right? Um, yeah, but this is how you create an agent anyway. Well, in Mastra, you have to compose it into the workspace. So we'll come and look at that later on. Um, okay. So now the next thing is you create an agent, and if you create an agent, then how do you give it tools? So you use this approach to give it tools, right? And you can define a tool by just using this construct. But you can also use Zod, which allows you to do more detailed kind of um, tool schema definition, right? So let's look at that example. Um, Let me take this out for now because I'll come back to visit that. To add a tool, it's actually very easy. Let's say tool equals so you first need to import the tools from here, right? And we import tool. There should be tool with a lower case. You also can do that uppercase one, right? Mastra has different ways that you can make tools. There's also create tool. So let's use create tool. So when you use create tool, you can then apply the create tool here. Again, you specify the ID, specify the name, specify the description, and then you specify the execute, which basically does something, right? It's a function that takes in an input and does something. But you will see this error, which kind of is Master is telling you you did not specify an input schema. So it is assuming it's just going to assign this input a type of any, which TypeScript doesn't really like that most of the time. So one way you can solve this is before you run the before you define the execute function that will execute that tool, you specify an input schema first. And then in the input schema itself has a schema, right? The input schema, you have to specify what type, right? Uh, the type is object. Okay, sorry, I forgot. This should be Zod, so I shouldn't go with this. So let's import Z from Zod. Now, because I am going to use Zod, I have to install it. So we'll do npm install Zod. Okay, so now the schema is defined using Zod, not this arbitrary thing here, right? So you start off with the Zod z dot object. So we know it's an object. And then that object deconstructs to have input. It only needs to have input, right? So this input matches this input. And then we define what that input is, which is a Zod string, right? And then you can give more additional constraints. For example, the minimum length is 1, and this will be the error message if that minimum length is not specified. So now this is still here because um, our linting has not yet caught up, right? But when it catches up, or the first time we run this anyway, because Zod is a just-in-time thing, right? If I run this now, let's see, then Zod will generate this schema and should not have the problem. Okay, yes, so this should be tools, not tool. The package should be tools. The package should be tools, not tool. And of course, that also throws this error. So tools don't have names. It's only agents that have names. Tools will just have the ID. So you can see this goes away. If I take away this Zod schema, right, execute throws an error, which is really the error I should have thrown, that you really cannot um, assign this the way we think. So you can see that in Mastra, the input schema is seriously integrated, right? So it becomes a requirement unless you don't take any input. And then if you return an output, you should also have an output schema. And in this case, since the output schema is a string, we can also specify the output schema. The output has a return value from the um, tool function. It's a string, and that works. If I were to change this to something like maybe number, you now see there's a disagreement. It's basically going to tell you that this doesn't work, right? It's expecting a string, not a number. So this is one of the really nice things about Mastra. It forces that type safety, that type sanity, and you find that this is going to save you a lot of time when you are doing stuff. Okay. Um, Now, if I run this because I did not do the right import, if I run this now, you will see that you know it works, it compiles. I'll come back to this, but let's go through the rest of the slides. So that's Mastra. You create an agent simply using this, and then you add tools using the create tool, right? Um, this example here is outdated, obviously, from what we have seen. Now, the next abstraction is the workflow. The workflow allows you to do what we call multi-step orchestration, where you can do multiple steps. Give agents instructions at steps, or do multiple agents, and each agent does a specific thing at each step. Right? In LangChain, this is essentially what is called chains, right? You are chaining runnables. In Mastra, you are building workflows and you are basically lining up um, agents, right? So agents are very nice, but production apps require multi-step orchestration. So, for example, retrieve something, then summarize, then store. That's 3 steps. Okay. Detect an intent, route agent, validate, retry. So Masra gives a lot of capabilities for you to do that kind of stuff. And whenever you want to create a workflow, you just import workflow from Masra core, okay? And then you create a new instance of the workflow, and then you give it a name, and then in the run function, you can then pass the different steps of the workflow. right? In fact, um, the way it works now is what you can do with workflows is you create steps, and then after you chain those steps, right? You create steps, then you create workflow that is made up of those steps. So let's try an example of that. Let's assume that I want to use the same agent I had created to, first of all, I want it to um, create a workflow. Okay, so to create a workflow, we'll first of all import workflows, of course. So import create workflow from Mastra core workflows, right? Then you will now create workflow. But for you to create workflow, you need to create steps first. Okay. So let's start by creating the steps in the workflow. A two-step, create two steps for a two-step workflow. So remember, this is what we're calling chains. So to create a step, you would, of course, also have to import a create step function, which is in the same workflow. So you have create step. And then, so the first step, let's say you wanted to, um, you know, fetch data from the internet, fetch a page from a URL, then summarize a page. Those are two steps, right? So the first step, which is to fetch the page, right? You use create step to create it. Then you would specify what that step does. So let me say fetch step. Let the ID be fetch step. Um, fetch content from the um, from the provided URL. So you see, we have said provided URL. That means that you can associate a tool, right? You can associate a tool to the step. Um, let's see what we have here. Um, or rather, you can associate the input schema first. Input schema. A function I wanted to say. Input schema first. So you are going to specify the input, which is the content. So this input should be the URL that you want to fetch. Okay. And let's just say Zod dot Zod has a URL. So Zod dot URL. Okay. Um, then that's all. You could add other things like timeout and all of that, but let's just keep going. Then you put an output schema. The output schema will be what it has fetched. Then you will now do the execution of this step. So the execution of this step, you just do a very basic thing. Okay, so I need to be careful here because it's telling me that the URL I defined is not correct. Oh yeah, okay. So I think I know what the challenge is. Um, for a step, what is the structured out here is actually something called input data. That's what it is called. It is not um, it is not what you define in input schema. It is called input data. Then from that input data, it now has this shape that you specify. So technically, what the Copilot is telling me now is, um, yeah, it should be input data.url. Or if we wanted to destructure it properly, we would have done it something like this. And then you would have URL. And then we can use the URL. So when you want to destructure for create step, it's slightly different. You can see it's slightly different from how the input schema for a tool is, which is a direct correlation of this to this, or the input schema for an agent. Okay, agent doesn't have an input schema. Well, it does have. It's just that we did not use it, right? But agent has um, if you have um, the additional fields or properties, but we'll talk about those later. So yeah, but the agent you just these are the four basic things you supply. Now, one thing I didn't do was I did not add a tool. There are two ways you can add a tool to the agent. One is when you are creating the agent, you just add it to the list here. So for example, I could have added tools here and I'll have a list of the tools which contains this. So let me call this agent one. Okay. So oh yeah, so there is also I think there is well, this is not the problem anyway. Yeah, well, one of the things that you find about Mastra is that you get the issues immediately, right? So you solve them immediately. So um okay. I think I see where this is where my problem is. So for Mastra, I'm so used to the other IDEs. For Mastra, when you pass in the tools, you're not passing in a list, you're passing in an object where one is the ID of the tool and the other one is the name. So I could say my tool, for example. That's what Mastra recognizes. So that when I want to reference any particular tool, I'll use this key that was used. It doesn't have to be what name it was given here, right? It can be anything. But if you want it to be the same thing, then of course you just keep it the same. So that's one way of adding a tool. But another way of adding a tool is after I have constructed an agent, like agent one, I can still use um okay, well there's no other one. I think that one that used to be an old way, but that doesn't work anymore. So right now you have to create the tools and then you assign it. So technically I should have created, you always create the tool first, right? Always create the tool first before um, you bring in the agent, before you create the agent, then we can pass in the tools, right? So, and then the workflow. So the workflow, again, you create the steps first. Then after creating the steps, then we will assemble the workflow. So In this case now, um, to now assemble the workflow, you now have steps here, which is the list of steps. Okay. So this list of steps, just like all the other things, it will have to have an ID. The workflow itself will have to have an ID. Then it will have an input schema because the workflow is going to take an input, and then you have an output schema. And this input schema is still Zod object. And yeah, we're still starting with the URL because even though, yes, we are doing a URL, that URL is going to be passed from the beginning of the workflow into the first step of the workflow and then into the next step and so on. Okay, then we'll have an output schema. So the output schema, right? Then you now declare the steps, right? Um, let me confirm this. So you have steps. The steps are not even necessarily required because there is another way you can um, actually dynamically add steps. I'll show you that. But if you want to statically add steps, this is how you statically add steps. You basically use steps, and then this time around you use a list, and then you put the steps. So if I had a step 2, I would have added step 2 here. So we could also make step 2 something like a const step 2, you create step, and all of the things in that, and whatever, right? So that makes it your step 2. So you create a workflow. So a workflow, think of a workflow like a chain in LangChain. That's basically what it is. LangChain actually makes it look much easier. But we'll see how we can assemble all of this later on with Mastra. One other way you can add a step to a workflow is you could also do something like this. Let me see if this works. Dot then. The dot then allows you to add new steps to a workflow. So for example, I could say dot then step 1, right? I can just say add step 1. When the workflow is done, then add step 1. Then I could do again, then add step 2, right? Or yeah, so we can keep doing chaining it that way. Um, this is a bit more advanced, so I'm not going to go too far into this, right? But um, this is something that you need to go and really study because there is something else that you do, right? Um, when you do dot then, the response from step 1 is what will be chained into step 2 as an input. So the reason why we are having this type incompatibility is that we need to repolish, the response from step 1 to fit into the input schema of step 2. The input schema of step 2 has content. So I need to polish it first. So the way to polish it is just like what we normally do with JavaScript. Use map and result. So remember the result from step 1 is just a string. If we look at this, step 1 just gave us a simple response or text that is a string. And it's even in the output schema, here's a string. So if the response from step 1 is a string, but the input schema to step 2 is an object that is made up of content string, then we'll have to reshape it. So to reshape it is why we use this map. So we use map, and map is able to reshape this thing for us so that the result okay, which this should also be destructured to match the output schema. Uh, that's what I expect this to be. Um, even though, yeah, there is an async here. This function has to be async because um, this map, the whole thing in master has to be async. So I know this is going to make things a bit more complex for you guys. So maybe I should have jumped into this one so soon. But yeah, so when you map this, you now map it into the shape that the next step is taking, which is an object that is made up of content that is a string. So we pass that into this. So that's why you now see this one works without any issues. So this is workflow. When you are done with all this workflow, then you can, um, you know, um, there's something called commit to save this because this one is for dynamic workflows, right? So in a way, what Mastra is doing is that if you use a static workflow where you have steps, you don't need to commit it. This is created statically. So this corresponds to the chains that we have in LangChain. But a dynamic workflow allows you to modify the workflow on the go, which is corresponding to the whole agentic React loop and all of that LangChain has. So that's just kind of a quick look into workflow. So workflow allows you to basically chain different steps, where each step can be anything, by the way. A step doesn't necessarily have to be an action of an agent. It could even be hard coded, function that you wrote already, right? So once you take something, you break it up into this, then you can declare each of this as a step, combine the steps. A step can also be an agentic, call where it calls an LLM that does something and comes back, and all of them are asynchronous. So you don't have problem with, you can see everything is asynchronous, async await, everything is async await, right? So, then there is stream, right? Now this stream is kind of a key requirement. I think I had already mentioned that um, even though my attempt to stream here, something was missing. So I'll I'll see if I can troubleshoot that at the end of the class rather than doing it in the middle here. But let's just go through the rest of it. So I don't need to talk too much about streaming. We've talked about it already. We've done it with LangChain. We've done it with other SDKs. Mastra is no different. It's the same thing, right? You begin to get the output immediately, right? And you just use agent.stream, okay? And you pass in messages. So again, this API has changed. It is no more in this format. It is actually just a simple, what I was trying to do here, right? It is just a simple, um, you pass the messages in this way, right? And ideally, you should actually be, let me see if this should be a function. It shouldn't. So something is missing here. I will check this out. But normally, when you get a stream, it is a link to something that you can then run, loop over it until it is empty. So that's basically, what we're doing in the stream at the front end. When you're displaying all those um, outputs that the LLM is sending, you're essentially looping. And that loop is an await loop. So you can see there's an await here. So what it means is that you wait until the next batch comes in and then you log it, right? When you log that one, then you wait for the next batch again, so on and so forth. And it's as easy as that from the standpoint of implementation. right? And it gives all of that. So that's streaming. Um, now, uh, so we already know what model context protocol is, so I'm not going to dwell on this. This is just a standard way for models, basically large language models and other AI models to interact with external tools, data sources. I think we did an extensive class on this already, and we even did another exposition on it. So the main thing is interoperability, tools being portable, safer execution, structured inputs, and all of that. So um, Mastra has MCP built in. We are going to see that when we look at the Mastra Studio. I'm going to try to pull up the Mastra Studio so that we can look at our agent and see how it works. Okay. Um, then memory. So memory is the other interesting thing, of course. Memory is what makes AI agents, even more intelligent because they are able to essentially remember previous conversations, and they're able to converse with you in a sensible manner because they can remember previous conversations, right? That's the benefit of um, the memory. So without memory, you tell something, you tell it your name, you come back and you ask again, and it doesn't remember, right? But you can see how easy it is to bring memory in with Mastra, right? So I'm not going to go through all of types of memory. I think we've talked about this already. Short-term, conversation history, long-term, user preferences, semantic embeddings. So Mastra also allows you to do semantic memory, right? Which is quite interesting. And then structured memory, which is you can store it as DB, database records, right? So yeah. So Mastra makes it really easy for you to you know, bring in memory. It has a whole section under memory that does that basically swap memory in, right? And you use the same memory class. So you use the same memory class, but you specify the provider. Okay. Then when you are creating the agent, you add the memory. That's it. It becomes very simple. Okay. So let's try that. To do memory is not yeah, we'll have to bring in the memory um Mastra memory, Mastra core memory. So we will import from Mastra core memory, right? And so you can easily add memory when you're creating this agent. So let's do that now. At this point, add add the memory. So const memory is new memory. And interestingly, um, let's look at what you have in here. If I use shift and space, so you can specify. Well, there are so many things that has come up here, but you should have provider. So this doesn't look like should have provider. Let me be sure I'm getting this correct. The type hints are not working. Yeah. Okay, so it is not just memory. You have different types of memory. Um, okay, so let's go with master memory. Um, again, their API has changed. So there used to be memory. It used to be just memory, right? But now, let's just go with master memory. So you can see there's a whole bunch of other things. There is mock memory. I'm sure the mock memory is for use when you want to um, do tests. Okay, so this should be master memory, which is what they were calling memory before. And you would have to pass in the config. So config is what we passed in before, and I want to see all the different keys. Again, yeah, so the config has ID. ID is not a required field, but the name is required. Okay, and then there's a shared memory config that you can add to it. So let's just call it, give it an ID, give it a name. I don't think the description is part of it. Okay, this is an abstract based class. So we, um, let's see what we have again. Okay, so we have different kinds of memory. Let's see if I can remember from my, um, I have used, there's SQLite. Let's see if we have SQLite. Um, P, um, okay, so, okay, yeah, so I think so what I have seen is that they have moved the memory. Um, so each memory is moved to a separate library. So the SQL memory I was talking about is libSQL memory, and it is now it was actually, it's now in a separate package. So as Mastra libSQL. So there are different types of they've basically separated out from the core. So npm install is libSQL. Yeah, that's what I was trying to remember. So you also have to install Mastra memory, which contains the actual memory. Mastra core doesn't contain the memory that I was looking for. Mastra core actually contains the base class definitions of memory. Okay, so um, we will import memory from Mastra memory, not from Mastra core memory, but from Mastra memory. And so with that, we can create a new memory. and we'll now get the right type hints. So let me use, so the right type hints, you can specify whether it's a vector memory. Vector memory is basically going to be attached to a vector store. So it's going to allow you to have embeddings, basically. So the memory is going to be semantic memory. Okay. We can look at that later on. The other thing you specify, I think the first thing you specify is the storage, where the memory is going to be stored. And let's see. So we have, if you want to store it locally on your local storage, for example, um, there are different values for this, but you have this is where we use this libsql store. So to get the libsql store, we'll import it, libsql. So this is just an example because there are lots of, there's a lot, right? It is not in Mastra memory, but it's actually um, in Mastra libsql. So you have libsql store, right, in Mastra libsql. Um, yeah, the Copilot is just messing around with me, but that's just to show you how fast these things are changing because Mastra is changing so fast. The Copilot is actually confused, it's left behind. It is old knowledge that the Copilot is giving to me. And so I have to be really careful not to go with it. So libsql store, for you to create it, just like everything else, you specify an ID. If I use control and space, it's going to give me ID, right? Okay, so we can just give it any ID. Then since it is a local SQL store, that means it's using SQLite. Basically, it's using SQLite. So typically you would give it an SQLite URL. Okay. So let's say, in fact, I can put this. I don't need an auth token because it's SQLite. So ID would be maybe my memory, my memory store, and the URL will be a file. So we could say file, and yeah, let's just store it somewhere close by. Okay. So yeah, I forgot the new here. So that is when you are declaring memory in Mastra, you specify a storage. And then the other thing you can specify are options. For example, um, the number of messages it should keep track of. So if I say last 50 messages, that's what will be stored. Then if you want semantic recall, right, true, right, then it will automatically have a vector storage, right? So that's how you create a memory. Then when you want to now do the agent, you pass memory in. So there's a key called memory as well that you then pass in. So you can see that we are gradually building up the agent from an initial simple agent that is just basically an LLM, um, you know, from here. We then added tools, right? And then now we've added memory. So now there's something that I was struggling to do. So I think I missed something. Again, the API changed. This part of it is correct. When you want to stream, okay, you actually await and get a generator. Basically, um, a streaming response will give you a kind of a streaming response. Think of it that way. And then Instead of just stream, it should have been stream dot um um it's now the reason why they kind of deprecated that stream thing is streaming for AI has changed. Before it used to be just text, but now you have structured data that also gets streamed. And remember, I said something about that. The method that is used or the protocol that's used is new line delimited JSON. JSON ND. That's what it's called. JSON ND is new line delimited. So if you want to get just a text portion of it, then you use text stream, right? And it will give you just a text portion. But sometimes you may want a more structured data. If the response is a more structured you know form, then you may want to get the full thing, right? So there is full stream, right, which will give you the full thing. Um, Even though I don't think this will work because by the time I get to the end of this stream, this loop will not run. But let's just see how this works. Okay. So I'm going to first of all comment out everything that happened here, and we will just run this streaming and see what happens. I hope TypeScript will allow me because there are a bunch of unused imports, which I hope it doesn't flag it. So node um, index.ts. Okay. Yes, so this I saw this coming because when we were creating this memory, I remember that there is an option to pass in a vector store, which is this vector, but I did not provide it, right? And here I am, I want it to be semantic recall. So I'm going to make it false for now. So it's just normal memory, not semantic memory. So it will not ask me for a vector uh, store. Because if it does, I have to go and create a vector store. Okay, so let's run this again. Now, um, so you see, it actually gives me, um, let's see. Okay, I don't have an API key, so let me set up all of that. Let me set up the API keys. .env. Um, I'm not sure if we wanted this process.env to load up, then we would have to get we'll have to go and get um, load.env, config.env. So I'm going to go get that shortly. But let me first of all bring the open router API key, which we will use. Since we've already specified that we are using let's see, we already specified that we are using here, we've already specified that we're using Nemotron. Okay, open router Nemotron. So you see how this one is much easier. We don't need to specify provider, even though this should probably still be a variable or something, but yeah, we can just say open router PI key, and then we can paste this value, which okay. Um, Now, for it to be accessible in the process.env, of course, we need to import .env and load.env. So we import config rather. We import config from .env, then we run config. Okay. And then I have to install config as well. So npm install config. Sorry. Yeah. For, .env is what I want to install. And okay, so that is done with a whole bunch of warnings. Yeah, so now I have my let's run it again. Okay, so let's see what the error is this time around. So it says user not found. What that means is that the API key that I put in there has expired. Yeah, I remember it was an expired API key. So let me quickly go and get another one real quick. Get API key that will last for maybe just 1 day. Testing expiration 1 day and copy it. Uh, okay. All right. All right. Let's see if this works. So now it works. Now, if you look at everything here, you will see that it is actually giving me delta as I am streaming. It is giving me structured. Maybe I should. Um, so what I did was I I did both, but let's take it one at a time so that we can really see the streaming. And this time around, I will also put a message chunk. Let me just call it chunk. Yeah. Um, it's not really streaming now, which is quite interesting. Streaming would mean I should have gotten the response immediately, but we are waiting a little bit. Okay. So this is the first stream. This is, you can see because I pull text stream, it is saying, hello, I am doing well. Thank you. So, of course, because I did console log, that is printing each of them out on a line, on a separate line. But ideally, you don't want to do that. You rather want to do process dot write writer dot write. Did I get that right? Standard out. Yes. Okay, I forgot that. So process a standard out. So, but we just print out just the message, right? We just print out just the message. We are not, this slash n will make each one to come out on the next line, which is not what we want. I don't know why the Copilot is suggesting that for me, but that's not going to work. So if we run that now, you now see, you see, it does that. Okay, the one thing that we should do is the last, it has kind of taken this thing up here, but we can always solve that by doing an empty console.log. Just do an empty console.log and so I don't leave any hanging messages. Now, let's um, let's ask for something long. Give me a 1 page dissertation on artificial intelligence. Now, this will be long, so we'll see the streaming here. And when we talk about streaming being like that is what today, that's like the minimum today. If you don't do that, it is not going to make sense. It's taking a bit of time to get started, right? But it will start up and hopefully give us something, right? So you can see it is streaming now. And this is actually pretty quick. As a matter of fact, if you wanted to make this is difficult for a human being to read. So if you wanted to even make it more user friendly, like we were talking about last week about, making your output more user friendly, you could actually put a little bit of timeout here. Um, how do we do timeout? Is it wait? Um, um, await. Okay, you could do await then, I guess. Yeah, so you do an await. Um, set timeout. Um, this doesn't look correct. Uh, so let's say maybe 100, maybe just 10 milliseconds. Well, it's going for 100 milliseconds. Right. Um, so we set timeout so we don't resolve the promise for 100 milliseconds, and we just we don't call it until 100 minutes. So this brings a little bit of delay in a synchronous manner. Okay, so we will now do the same thing, and you see the difference in terms of how much nicer it looks for a user, because the other one was still too fast for me to read. But this one, it will take a bit longer to stream the whole thing, but I am able to read, which helps. But sometimes this may not be the priority of the user, making so the person can keep reading what is going on there, but just to generate it. Okay. So anyway, but this is text stream. We are pulling just a text components of it. The interesting thing, I'm not going to wait for this to end, so I'll just terminate it. The interesting thing is that's not the whole component of the streaming that is coming back when Mastra gives you streaming. It gives you um more. But when you take text stream, you're just taking only the text component. Now you can also do the full stream. And this one will use console log so that you see the whole thing, right? That's what we were saying before. And yeah, let's add the timeout as well so that it kind of delays. Um, Again, this are I'm going to put a 1 second delay between each. Okay, it's still going to be a one-page dissertation, so it's going to contain a lot. We're not going to look at everything, but at least it allows us to see. So if I run this, you see the payloads are coming now. You can see. But the structure here is the text is actually just one word. Maybe here is a whole word. Sometimes it's a single character, right? Sometimes it's a piece of a character. But in each of them, it comes with a bunch of additional metadata. The type here is reasoning delta. The run ID is this from agent payload. So this is just telling you that streaming is not just the response, the human readable response. Streaming includes the additional metadata that comes. And if you were streaming this, you would have to kind of figure out a way to still pile them together, right? So this is just to show us what happens in streaming. But let me terminate this also. All right, so that is streaming, and we've looked at memory. So let's now now that we have this, right, let us now make a conversational. Now, for us to have memory, to demonstrate the memory, this thing is still wasn't able to terminate it. Okay, it's terminated now. For us to have a true conversation, right? I'm going to go back to us just doing the text stream. And um but before I go into conversation, because of the time, and we're kind of running out of time, but I want to round up, right? Let me bring all the other things back in and let me just finalize everything so that we will put on the Mastra Studio. And then instead of what I'm currently doing here, I cannot really do conversational here because I have to go and start writing all kinds of additional code, which Mastra takes away from us. Mastra takes away all that stress, right? You don't need to write out the harness, the playground that you'll be using to play and test out your agents. Mastra has all of that. The only thing you need to do in Mastra is to build the agent itself. So let's just quickly run through and get to the end. So I've shown us how you can add memory, right? This is just one case. You you get memory from Mastra memory, and then you get a memory store from Mastra libsql. So in this case, we're using libsql store. So before you create the memory, specify the storage. And this store can be anything. You could also have an in-memory store. You could also have a PostgreSQL store or Redis store. They have a lot of them. Just go check their documentation and so on. So now, so that's how you bring in memory. Okay. The memory allows you to keep track of what is going on. Um, you attach it to an agent that way, and that's simply it. Then RAG. Um, to make a RAG is not um, difficult either, right? We've already talked about RAGs, so I don't need to explain what the RAG is. You only need to make a vector store and then load that vector store with data, and then after that, um, you attach it to the agent. Okay. We'll look at vector stores later on. I don't want to um, we also have workspaces. We'll also talk about workspaces later on. Um, but let's talk about the server. So the server allows you to plug your agent into it, and then the agent becomes essentially a backend, and you can do everything with it. Okay. So let's do the server, and then we'll end that today. We'll do the server, we'll do the studio. I'll show you how the studio looks like. We'll play around a little bit with it, and then we'll come back and do the rest, including the two that we have skipped, the um, RAG, workspaces, observability, evals, and all the rest of it. But a server is not difficult, right? You create a Mastra server. But here, Mastra imposes some kind of requirement. Mastra server will not run if you have it directly on, you know, um, if you put your index.txt directly, Mastra will not run. Typically, the way you run your Mastra server is to just run npx Mastra or something like that. Right. So let me show you. So to start, right, you would start by let's try starting Mastra Studio. Okay. So to start Mastra Studio, you first of all run npm install, right? G Mastra. Okay. Or pnpm, install. That's how you start. So this is the whole infrastructure that allows you to bring up the Mastra Studio. That's the first, that this is what you first do. Um, so while this is also running, um, the second thing is you can now start the Mastra dev server. So I think Mastra is installed. Um, we had already installed part of it anyway when we installed the Mastra CLI, sorry, the Mastra core and libsql and all of that. So we had already kind of done that. Now, if we run npx Mastra dev, this is how you start the Mastra Studio. But Mastra Studio is going to look for a folder called source Mastra index.ts. This is what it's going to look like. It look for. And in that source Mastra index.ts, it's going to look for a Mastra instance. Okay. And that is what it uses to boot itself up, to configure itself. So we don't have that. What we actually have is just an index.ts, right? We can convert this our own index.ts and just move it. Let's just move it into that folder. So let's create that folder, src Mastra, right? To create that folder, src Mastra, and then we'll move our index.ts into that folder. So we now have a source Mastra index.txt. But that's not enough because the second requirement is that we have to have a Mastra instance. So for us to have a Mastra instance, the Mastra instance is the Mastra server, right? Which you just do Mastra equals new Mastra, right? Again, this is kind of outdated. So I will just create a new instance of Mastra here. And then bring in all of the things that you want to bring in. So you first of all, of course, have to import the Mastra itself. So let's import that. Import Mastra from Mastra core. Okay. And we'll just start with that for now. We have an agent that has memory. We have a workflow that we have created, right? So those are the only two things I'll put in that Mastra environment. So this Mastra is a Mastra environment. So to create a new Mastra environment, basically, or sandbox or playground, right? A Mastra instance, I'll just create that. So that will be new Mastra. Then you specify the agents that you want to have in there. So right now, I have just one agent. Okay. So let me call that agent one. And the value of that agent is agent. And I also have one workflow. So let me call that as well. Let me call it workflow one. Okay. All right. So I'm not going to have anything else for now, just those two. Um, we could have a server as well, right? That allows an external, basically, if you have a Mastra server in here, right? If you have a Mastra server in here, that means you can create an endpoint and that server can be connected to on that port. But I don't want to have a Mastra server yet. I just want to have Open Mastra Studio with this Mastra instance and this one agent I had and this one workflow. So with that, now I can rerun this npx Mastra dev. This file is now in source Mastra index.ts, which is what it is looking for. And there's a Mastra instance in there, which is this Mastra instance. So once you do this, then the Mastra Studio will come up and you'll be able to go in there. It's a user interface, basically. It's a UI environment that you can play around with. Okay, so we have a bunch of errors. Let's see. Uh, bundling failed.
I
It's
think you
not.
missed the part that says something is missing. If you scroll in, scroll to the,
Yeah.
just scroll slowly. I saw something like missing. Uh, s-
Okay, so this is it. Um, Master is not exported. Yeah. Okay, I should have exported it. So I think it should just be export. Um, let me let me see.
export new master.
Yeah, it should just be export. Yeah, I think we export it, not new master as it is, but we should export it. Yeah, I missed that. Okay. Okay. So I need to take this off. I should have removed the streaming part. So it's still streaming the AI stuff. Let me take that part off. Let me comment out that part. So we don't need to do that anymore because this agent is now part of Mastra Studio. So we can interact with the agent directly in the Mastra Studio. We don't need to use because doing console log here is just like you doing console log instead of having a user interface where you are directly, interacting with the agent. Okay. So Mastercard normally, by default, it runs on this localhost 4111, which code spaces has forwarded it for us. So we can just open it in the browser. And if you want to do an API call, you call it through 4111/API. And it's watching for file changes because it's in dev mode. So, so this is Master Studio. Um, so allow this. So the instance URL, now this is where I'm a bit, I need to figure out whether I think I should use what is here so that I can access it. It is what is publicly accessible, right? And the API prefix is still a /API so that I can access it, right? If that doesn't work, then I will go with localhost. I'll just go with the localhost with the default values. And yeah, HTTP. I think it is doing this because it is not able to access it. So this is one of, I've not done this on a code spaces before. So, oh, okay. I know what the problem is. The port is a forwarded port, so it's not available on that forwarded port. So this is correct. It's HTTPS that, but the, oh yeah, okay. Then the API is slash API. Let me try this again. All right, so maybe the slash I put at the end. So we are in Mastra Studio. If you go to agents, you now see that there is one agent here, which is the agent we did, right? And if you even look, you see the model is NVIDIA Nemotron 3. Um, this is the number of tools available, number of attached tools. There is one. We just attached only one tool. If you go back, you look at the tool, you see the tool we attached to it. Um, yeah, this create tool. So you can play around with this here. You can actually just chat with the agent here. That same give me one is a single page dissertation on artificial intelligence. And that's it. You have a very easy, you even have reasoning. You even have reasoning. So the beauty of Mastra, you see the tool call as well, right? You see the tool call. Um, the two results you said right. So our two call did not do anything. Our two call was just to return the value. You said blah blah blah. So Mastra actually made that two call, but nothing came out of it. So this is the reasoning, and there's a final response. And see the final response here, and it's well formatted and everything. So Masra has taken away from us the drudgery of building a playground around our agents. You only focus on just building the agent. And if you build your agentic framework very well, you don't even need to build agents anymore. You just build an agent and you can build a generic agent that will load from, you know, load prompts. So you can be throwing in prompts and so on. Add your tool calls and you can then do testing here. It has a lot of stuff. You can see the MCP servers I talked about. You've not configured anyone. When you configure, they will show up here. Workflows, we did one workflow, so you can see the workflow that we did here. Remember, we attached one workflow. You can even see the three steps. I think it was, yeah, I think it was two steps, and then we dynamically added another one step. So that's three steps. And you can run the workflow by clicking on run, right? Since you are defined with Zod, this thing gives maps to Zod. So you can actually see the input schema that we had defined with Zod for the workflow, right? We have created a step called fetch step, and you specify the Zod schema, input schema, a URL. Even though we did not do anything much with it yet, which that will be part two when we come back to actually turn this thing into something interesting. And then here we had done the create workflow here, right? Where we combine it, but even in the create workflow, we had specified the Zod schema. So is this schema that is using to now ask you for the URL, which is required. So if I just say HTTPS example and run, it's actually going to fetch because remember our thing was a fetch step, right? And it's giving us, yeah, it worked. And then the mapping step, but the process step fails, right? It's red. That one wasn't done. The process step was just, where is the process step? We mapped this and then we did step two. So step two, um, where's step two? Process content length. So something is missing there anyway, right? So workflows allows you to build some complex stuff. Basically, what LangChain is calling chains. And these are the inputs. You can see URL is HTTP. It allows you to inspect stuff. And then this is a response, which is the actual HTML from that is passing as value. Remember, we in our intermediate, okay, the output is value. But I think the problem is now the response from that step is response or text. Um, we just chained them together in the workflow, which is step one and step two. Then we still added step one again at the end, then added step two again. So we effectively added the two steps um, over and over again twice. So I wasn't trying to do anything very, you know, practical or useful. I was just trying to show examples. If you check the tools, you'll see the two calls that we had defined that you can even call. This input is the URL or hello. Okay, this is a tool that echoes back what you said. You said hello. So Mastra, everything that we put in that workspaces, we did not create any workspaces. So we'll talk about that when we come back. The interesting thing is that from Mastra Studio, you can do overview of the entire thing. You can also do experiments. This is where evals and so on comes. You can have data sets and set of experiments. And then evals. You can look at metrics. This is observability, like we talked about, metrics, traces, logs. Um, we did not tie observability. We didn't configure it. So everything just boils down to configuration. And this becomes a very powerful tool for you to be able to just iterate with your agents. Remember, in today's AI world, agents are really just about tools and prompts. Tools and prompts. Maybe you can add memory, but what you won't do much with memory. You just configure it and let it ride. But the things you're actually going to be fine tuning to improve your agents to make them better will be your prompts and your tools, and maybe your workflows, your chains, right? Mastra gives you a very powerful environment for you to do all those experimentation without having to write too much code. The only code you write is the code that sets up the agent, sets up the tools. The prompts are things you can, you know, modify. So that is the introduction to Mastra. Are there any questions?